Alright, so we start off from the previous tutorial, and in this tutorial we'll go more in depth. Oh, let's stop talking and let's just make videos, the tutorial. So we'll make a new class. We will make a decorator which fails. It will be very quick. You can skip that part, but go to all classes, find BT decorator. And let's click next. We'll call it PT Decorator Force Fail. Create class type public, create. Now we wait. Okay, after it finished, we want to open that. So I have it opened here. So let's get rid of the rest. I'll just delete them. So we have clean header file and C++ file. Let's change it to 16. So we have this, and let's see the decorator that is most similar. So this is also a good tutorial just for you to know how to work with Unreal, because there's a lot of looking at how Unreal works and copying that and changing a little bit. So we have BT decorator. We want to look for force succeeds, because that's the decorator we want to copy, but we want to change it a little bit. So let's open the header file first. Then I will just open the C++ file. I have a shortcut Ctrl Q, which switch between the header and C++ file. So let's go down, and my head is in the way, so that's not good. I will move the header file to the right. So I have this function called onNodeProcess. Like, we have this function onNodeProcess, and this is the function that we are interested in, because getNode icon name, it doesn't matter, because it's basically for visual purpose. So let's see how it works in C++ file. If I switch, you can see that we have a constructor which basically sets the name for succeeds. We will copy that. We have this macro called need decorator node notify flags. Basically what it means that if you go into it, I can go into it by control left clicking. It defined this thing, this block of code, and what this block of code does, it basically tells Unreal that we want those functions to be called. So we want on become relevant to be called, on cease relevant, on node activation, deactivation, and on node process, which is the function that we are interested in. If we didn't call this function or macro, then this function wouldn't be called. So we need to have this in order to have this called. So after that, we have three properties that we change to false. So allowed abort none, allow abort lower priority, and allow abort child nodes. So we don't want this decorator to abort anything. It's not relevant in this tutorial, but just know that this does what I said. So let's go to the meat. We have onNode processed, and inside this we just change node result to succeed, and that's it. Then we have this search log. I don't know what it does. It's probably just logging to editor, so we don't need it. This is what we are interested in, so we just copy that and we change it to failed, and we have force fail. Easy. This onNode process, it's called at the end of the node processing. So if you have the wait node that waits for 5 seconds, it will start, then it will wait 5 seconds, and at the end onNode process will be called, changing the result. So it won't change the result immediately to failed and abort immediately. So it will wait till the task finishes, and then it will change the node result. So with that in mind, let's do the same. We need to make a constructor. Let's call it force fail. Like we don't have other options. We need to call it the same as the name class. With it will also take this object initializer and writer tells me to make it explicit here. Okay, let's generate that. It will jump here. Now let's move back to for success, change to header. Let's see the definition of this function, the signature on node process. So let's write on node process, and writer will help me and show me the signature. I can press enter and it will show up. Now we can generate the definition and we have it on the right. So if I move for success to left, we can just copy that. Let's make this body wrap lines and we can just copy that. Just copy from the success, paste, let's call it force fail. We have init decorated node notify flags, false, false, false. And here we don't call super, we call node result equals ebt node result fail. So right now it will fail the task that it's wrap around. And we can also copy this part, paste it because it's a log forcing, and we just can copy, change the name, forcing fail. And that's basically it. And yeah, also we can call the super of this decorator and pass in object initializer. And I remember now that we also need to change it in the composite node we created. So let's go to random selector, go to C++ file, and here we also call super and pass in object initializer. So the parent constructor will also be called. So let's rebuild this and see if it works. Okay, I have this small side note because Rider auto includes things for me. So if for some reason your build doesn't build and it shows error, try go to your solution explorer here, go to your uproject file and make sure to have this AI module included. So we have the project opened finally, and right now we have the force fail node, which will basically fail. So if you go to BT tutorial, AI again, now we should have, if we zoom in, we should have the decorator, which is for force fail. So we can copy that, and let's move this for a second, and let's select the selector node to see if it works. Okay, so right now this should fail after 5 seconds. It should move to the next one, also fail, and it should move to this one, and then after that it should return to parent. So let's start. Let's see if it works. Start 5 seconds, we need to wait 5 seconds. It will move to the next one because it force failed. Typically wait succeeds. So it force failed this one, and this one should be succeeds, it should go up. And as you can see, it works. That's good. And now, thanks to that, we can finish our composite node. So let's do it. Let's open our code editor and let's open the random selector again. Okay, so we have this random selector node. So what we need to do now is to store which child we already processed, so it won't repeat itself. It won't repeat the same child again. So in order to do that, we need to go to the header file of the random selector, and we will need to create something that is called memory for the node. So basically the behavior tree nodes, they store the memory in the struct. So we will create a struct that will hold the array of childs. So let's start. We will have struct declaration, and it needs to be like normal struct, not Unreal Engine use struct. And let's call it F for naming structs. F is for naming struct, et, and we call it random selector memory. It needs to inherit from FBT composite memory, which is struct for storing memory, but we can expand to make our own if we want to store more stuff or different stuff. But we will basically just store the array of int 32, if I remembered correctly. Yeah, because they are indexes, and we will call it children ID. So this will remember which ID we already processed, and it will tell us what IDs are left to process. So we'll have that, and in order to use that memory, because by default each node use this memory, like composite nodes use composite node memory, but if you want to use our custom memory node, we need to override one function which is called get instance memory size. And let's generate definition. As you can see, here's the signature. Is it big enough? Okay. And basically what we need to do is to return the size of the memory of the struct we just created. So the composite knows what size to allocate of the memory. So that will be simple. You just return size of, which is a function size of, and we write the name of our struct, fbt random selector memory, and that's it. We need to have this in order to use this memory. And don't ask me why we can't just store it in the header file like the TRA, why we can just store it here, because this node, I think it's not instance, which means that you can store the state of the node inside the header file. We need to store it separately in a different struct, because it's not instance, and that's why. That's a brief explanation of it. With that done, we can move on to our next function. We'll also need the function called node activation, notify node activation, which will be called at the beginning of the subtree. When it enters the subtree, it will be called at the beginning. And let's generate the definition for it. It will be here. I'll move it up before get next child handler. And the same thing as with the decorator, we need to call the macro to call those functions, because by default they are not called. We need to call this macro called init composite node notify flags. So if we call this, this function will be called by Unreal. If not, it won't be called. So we can delete that. And inside here, we need to clear the memory, because we want to start with the fresh memory. We want to have all the childs available, because by itself the memory that we just created, it won't be cleared. We need to manage the memory by ourselves. So let's create the memory variable, and let's call it my memory, and we want to get node memory, which is a function to get a memory of the node. And here we specified the memory type we want. This is a generic class, a generic function, so we can specify any memory node, but we want our one that we created, random selector memory, and here we want to pass the search data. So basically the search data contains the memory, and I told you that I will explain it before. So basically search data contains our memory, we can cast it and get our memory from it. And it shows me red squiggles because we need this to be a pointer to our memory, so we want to create copies. And with that, now when we have our memory, we want to clear the child. So we want it to be fresh and clear, so we want to access my memory, we can access children ID, and we just empty that. So now we have empty array in our memory. And now we want to add indexes of each child that we have. So we'll go through the for loop. For I have this macro, it finishes, writer finishes, right there auto completed that for me. Int, we want to start from I equals 0, and the max is get children number, get child num, and then we increment the I. And here we just add to our memory the index of I. So it will store, if we have four childs, it will store 0, 1, 2, 3. If we have 2 childs, it will store 0, 1, etc, etc. So right now we have all children IDs that are available to be used, and that hasn't been processed yet. So we will remove, after each iteration, we will remove from this array and see which childs are left. Let's go down to the get next child handler. So now we need to access our memory. So we get the same line as this one. We can just paste it here, so we have access to our memory. And this time we want to, instead of the get children number, we want to access my memory, we want to access children ID, and we want to access its number, and -1 because the index starts from 0. So basically this line will return the index of the child that we want to use. So we don't want to assign it to next child index. So let's make a temporary variable. Let's call it random index. Random index. And in the next line we want to assign next child ID to my memory, children ID, and access the random index. So this can be made const, as the writer suggests. So this is our first line. It will just get the random children. It does basically the same, but we want to specify, like to explicitly say that we want to use the children ID instead of get children num. But the previous one was also correct, because the first iteration doesn't really matter, because we still have the maximum amount of children available at the start. But let's leave it like this, because it's more like clear why we have this my memory struct. Okay, now let's go on to else if statement. So here is the second time when we iterate over the tree, and we want to remove the children that we already processed. So we will access my memory, children ID, and we will just remove the previous child. Previous child comes in as the argument here. So it will remove the child that we accessed here in the first if statement. So next time we enter this condition, the child won't be child index won't be available again, so it won't repeat itself second time. So that's why we want to remove it. And right now we can access the rest of the child. So here we just copy paste from this number, because this number now is different than the get number child, because it can be free. For example, if you start from 4 childs and then you remove one, you have 3, and now we just get random range from 0 to 3. So it won't take into consideration the other child that we just removed. So the same case as here, we want to make a temporary variable called random index and store the random index of that child here. And in the next line, we assign it in memory, children ID, random index. And with that, we are almost done. We just also need to wrap this in separate if condition, just to make sure that we are not out of range. So if you are at the last child, so for example, you have 4 childs and you iterate over 4 already, and next time it will enter, we don't want to access another child, because the memory would be empty, because we would remove all the child. So there would be no more child to check, and this would crash. So we need to add an if statement to see if my memory children ID is empty. So we only want to access the children ID when it's not empty. So here we need to add an exclamation mark just to negate the condition. So with that done, this should work. So if we recompile this, rebuild this, it should work. So let's see. All right, we are back to the editor. Let's see if it works. Let's see BT tutorial. Again, just Ctrl P and search for it. BT tutorial AI. Let's see. Okay, we have random selector. Let's delete that. And if I remember correctly, did I change to failed or not? That's the question. Let's see. Okay, we have random selector node and we did change to failed. Okay, so that's good. We did change to failed. So basically, if it fails, then it moves to the next random one. And let's see. So we basically needs to add this force fail to each one of those. Let's see. Play. Open the behavior tree. It starts from the first one, then it goes to the last one, and it should choose either this or this. And now it should choose this one, and then see, yeah. So it works. Now after this one, it will go up to the root. As you can see, quick flash. Did it though? I don't know. I didn't see it, but I think it starts from this one. Now it, okay. Move to this one, then move to this one. This will be now, and after the 5 seconds, it should go up. Let's not touch this. Maybe it's too quick. I don't know. It's hard to say. I think it's too quick. But yeah, that's the tutorial. And I hope you enjoyed this. You can also change this to succeed, to success. And if you change this to success, you basically get random sequence instead of selector, because it will move to the right as long as it succeeds. So you already have 2 custom composites node, and I hope you enjoyed this tutorial. It was quite long, but C++ stuff are long, and it's something that you can't omit. And I also wanted to say that I'm not an expert. Again, I'm not an expert in C++. I'm just learning. and try and error things, but I think it's still good to teach others and to share this knowledge with others, and I hope you can gain something from this, and I'll see you in the next tutorial. So goodbye. And if I did something wrong, I know that it can be refactored, then just let me know in the comments. And yeah, that's it. See you. Bye.